Hi class, this is the review video that's going to go over the t-test, the pair t-test, the dependent t-test. The data all comes from the same general idea of comparing students with COVID and without COVID, with the dependent variable being stress levels. We're going to keep two very similar, the same numbers throughout the three different research designs and the three different t-tests. So feel free to fast forward or pause, look through whatever you need to for this review video. Thanks.
Hi class, we are reviewing our three test statistics we've learned so far this unit. Our first one comes from chapter 8 when we learned about Z with the distribution of sample means. And then that same formula was used in chapter 10 when we introduced null significance hypothesis testing with Z. So we have a problem with this made-up data that I've got where we've got community college students and our special sample is those with COVID, and we are looking at stress as our outcome measure. So our sample had a stress score of 13. Our population, just the general population of community college students, has a stress score of 10. We then have a sample size of 26 and a sum of squares for our population. So this is population data with Z as 250. So the first thing we're going to do is we're interested in looking at, are there differences of stress levels between those students with COVID and those without? Again, the default is 0.05 and a two-tailed test. Remember, two-tailed test is non-directional. So step one, I would like you to set up your null and alternative or research hypothesis. So pause the video, go ahead and do step one in words and math, and then check your work in just a minute. So again, step one is always in terms of population. So we're going to use muse. Null is nothing, nada, no differences. Again, two-tailed test. It's not directional wordages, it's no changes, no differences, etc. Step two is gathering our critical value, cutoff score, critical region, cutoff boundary. And with Z, we have a set. So with alpha 0.05 two-tailed test, that is 1.96. Again, you are going to have two critical values. That's going to help us with decision making. Fail to reject the null, reject the null. Step three is using our formula. So our formula is, is this guy, all right? This guy, we do not have our estimated standard error. We have to get that from knowing our variance or knowing our standard deviation. So we don't have variance or standard deviation, do we? We just have sum of squares. So then we have to remember, back in the day we learned that we had these two options. Oops, I should say that's variance. And taking the square root is the standard deviation. It's a little too rushed on there. So given that we have sum of squares, I'm probably just going to do this guy so I don't have to take that extra step. So let's go ahead and do that first. So step one is using our sum of squares and our n. And again, our n we need for the degrees of freedom. Degrees of freedom is 1 n minus 1. All right, so we are going to go ahead and do the variance calculation just so I don't have to do that square root. So again, 26 minus 1 is 25. So then I get my variance of 10. I then can use that variance and use that in here. I just have to remember I'm going to take the square root of everything. So then we are going to have square root of 10 over 25. And then I'm going to have to, oops, I already made that mistake. It's 10 over 26. And that's actually a silly mistake many of us will make because we're in that motion of just have used degrees of freedom. And again, it is n that we're using. So then we are going to take the square root. Again, use your calculator. Go ahead and pause and do that. So I'm going to take the square root of this guy. And then we're going to get an answer for that, and I hadn't taken that yet, gotten that far. So just give me 1 minute. All right, I then get 0.62 and it tangled off, and usually I'll do 3, but the last one was 0, so we'll just keep it at 0.62. I then am going to go ahead and do my Z. I had my sample as 13, my population as 10. That's going to be over 0.62, and I'm going to have 3 over 0.62. Again, go ahead and do this along with me. And I get 4.839 if I round. I then am going to take that 4.839 and compare it to my critical values. And mine is way out here. And actually, if you know Z, we know it's usually a range between -3 and 3. Again, this was made up data, which is showing it's very large. So then step 4 is making my decisions with my 3 statements. So I'm going to reject the null. Again, why do I reject the null? I'm in the critical boundary, critical region. I'm past that cutoff score. Rejecting the null means there's statistical significance. And then that also is going to bring me context to my problem. So my problem was about students stressed with COVID. So I can say students with COVID have greater stress. Again, I can do a directional statement because I've run the test and I know it's above. All right. Okay, so that's my null hypothesis testing. Now, the best thing we can do now with new statistics is to always check, well, what's the magnitude, what's the size of this effect, or do I have a risk of a type 1 or type 2 error? We just learned Cohen's d. For this, for Z, all right? So we're gonna use that formula. So again, this is the same as the top of my T, but the difference is now I am using my standard deviation. So I had gotten 10 as the variance, and again, so I'm not asking for variance here. This is standard deviation, so I'm gonna take the square root of 10 for that. So I get 13 minus 10 is 3. The square root of 10, it again gives me some numbers, but I'm going to go ahead and cut it off after the 3rd digit. That's 1.62. So 3 divided by 3.162 equals, again, some rounding, 0.949. All right, so then if I look at my D, my Cohen's D chart, if a D is greater than 0.8, it's a large effect. All right, so I would say it's a large effect. That's great. I do not have a risk of a type 1 error because I had a large effect for step 5. We are now going to move on to our dependent or paired t-test.
Your dependent t-test, we're going to be going through that next.
So we are carrying on with the same example. So we've got our IV is COVID, community college students, or students before COVID, after COVID, with the pre-test, post-test design, and our DV is stress. Just for the sake of comparison, I'm keeping our numbers and our data as similar as possible. And that's what you'll see with research methods, depending on, you have a research question, so do we see differences in stress with students with COVID? You can use a different ways of designing and for your research. So here we have our difference score pre-post COVID for this fake data was 3. We have our sum of squares doing our difference score as 250, and we have 26 students participated. So again, a t-test is 2 scores, pre and post, t for 2. There's your little t for 2. All right, so the first thing that we're going to be doing, and again, if I didn't give you the mean of D for difference score, you might have gotten the sum. All right, and then you use that formula. Okay, so step 1 is our hypotheses. Go ahead and take a pause. Again, words and math, you're going to be setting these up just like I am. Again, when we do this, we can do this a couple of different ways. And either one of these would be acceptable to me. because this is time 1, time 2, time 1, time 2. And again, your null is always that equals. It's the same, no differences. And again, I'm going to put this in words as well. So no differences in stress after COVID, and then differences in stress after COVID. All right, and again, if I don't tell you, it's alpha 0.05 and a two-tail, because that's the most common in the research world. Step 2, now you have to use the t-distribution table. Right, so this one you would have to do that. For the exam, I'm just going to want you to tell me the degrees of freedom for the chosen test statistic you're using, and then I will give you that critical value if you're working with t. So our degrees of freedom, we had 26, so that's 26 minus 1 is 25. If I were to look at the t-distribution table for having 25 as my degrees of freedom, so I have the degrees of freedom here, and then I have the alpha and the 1 or 2 tails here, and then I match them. When I look at that table, I should get a critical value of t plus or minus 2.06, right? So that's going to be, again, my decision maker here. All right, step 3 is using our formula for t. So we do have a new formula looking at our mean difference over our estimated standard error, right? And again, I'm not given this, I was given this. So we're going to be working through that. To work through that, it's going to be very similar to our t. So first we have to get our variance or our standard deviation. Again, since I was given my sum of squares, I'm just going to take one less, and I'll probably use this one. All right, so I'm going to get to variance, and then we use that variance to get to my estimated standard error. So again, we had 250 here, and we had 26 minus 1 is 25. So I get 10. I'm now going to solve for the bottom of my t. Again, there's 2 different ways you can do this. All right, so again, that's this guy equals your variance over n, or you could have done standard deviation over the square root of n. All right, so I could have done either one of those, but again, I'm just, you should get the same answer with everything, but again, so I'm going to use this one for the example. So I'm going to take this, again, that square root of 10 over 26, and that is pretty much what we had done last time. Again, we're just working with different data. All right, so that's going to be that. So then here our t is going to equal 3 over 0.62, and we are going to get 4.839. We're going to compare that 4.839 to that 2.06. Again, we're out here, and then that's going to lead us to our step 4. Sorry for the wiggliness. Okay, step 4. All right, I am going to reject the null because it was greater. All right, rejecting the null means it's statistically significant. Those two things go together, and then students have greater stress with COVID. Very similar to our Z. But in this time, we got individual differences because we did stress before COVID, got COVID, then stress after COVID. All right, so let's now do our effect size. Effect size for T, you had 2 different ones. All right, you had R squared. You also still had Cohen's D. All right, so we're going to work through both of those to get practice with both of those. If I do not tell you which one to do, you can do either one. They both are going to, again, you're going to need to add that interpretive statement. All right, so take a moment to plug and chug and work through those. So we had this, we had your t equals 4.839. You had your degrees of freedom equals 25 to work through that one. And this guy, we had our mean difference of 3, and then we had this guy as negative 10, or negative 10, the square root of 10. And when we take the square root of 10, that equals that 3.162. All right, so pause and work through both of these. Okay, so working through our D, plugging and chugging, again, it would have been very similar to our Z because I was using the same made-up data. You take that 9.949, and that is greater than 8, so we have a large effect. Very strong finding. Our next one, plugging and chugging, again, we're going to take our T, take our degrees of freedom. We're going to work through those calculations once we get that. For R squared, it's not necessarily a factor of small, medium, and large, though I did give you that screenshot to do to identify those. But you can take this and talk about it in terms of variance. So 40.484 as a proportion is 48.4% of the variance in stress. So 48 point, almost half of the variance we saw was attributed to COVID, getting COVID. Again, this was individual differences. And so that is also a large finding. So now we are going to move on to an independent t-test, again, using the same example.
So we are on to our last test statistic, the independent t-test with 2 groups and a between subjects design. Enjoy.
Okay, we are on to our last example, and this is T for 2, where you've got 2 separate groups. So we're going to have one group that, for this example, was stressed and COVID, one group of students that did not get COVID, and that's going to be that group 1 of 10, one group of students that did get COVID, that's going to be that group of 13. Our dependent variable, we're still looking at stress. Again, I was just playing around with the same sorts of context for data. So here we have group 1 was 13 people, and group 2 was 13 people. Sum of squares for group 1 and group 2. So that's our starting information. So again, take a moment and to work through our hypotheses. So we've got H of O, which is our null, and H of 1. And again, these two ideally is the same setup. All right, so again, no differences between the populations with stress. Again, always in terms of a population. Differences in stress between the populations of COVID and not getting COVID. Okay. Step 2 is finding our critical value. Again, you have to use that t distribution table. All right, and again, I would give you that value, but then you're going to give me the degrees of freedom. Degrees of freedom is a little bit of a change up. We have 2 groups. So it's going to be degrees of freedom 1 minus 1 plus degrees of freedom 2 minus 1. All right, so that equals that 13 minus 1 plus the 13 minus 1 equals the 24. You could also have done 13 plus 13 minus 2 and gotten to that 24. When I look up the table, again, the default, unless I tell you differently, is 2-tail alpha 0.05. When I look up that critical value, I get a plus or minus 2.064. Okay, that is my decision maker. Critical value, cutoff region for our deciding. Step 3 is working through our formula. All right, and you can see our formula's mean differences over standard error. That was our formula for T. That was our formula for the pair T or dependent T as well as Z. It's all the same, but the context changes because of our study design. Okay, so we do not have our denominator. To get to our denominator, we have to first get to variance. So this is our new pooled variance formula. All right, so then I want you to take a moment, plug and chug those numbers given to you. Again, you're not going to do 13, you're going to do n-1 and n-1 for those. So we've got 120 plus 130 over 12 plus 12. Okay, and then we're going to go that's 250 over 24. And when we solve for that, again, pause and take a moment to work through this on your own. We get that 10.14417. We then are going to use this in that formula, estimated standard error formula. And again, I want you to make sure that you've written and separated that appropriately. So we do these and these. In this case, our ends are the same, so it's going to be similar. Both of these are going to be identical. Your ends might not always be the same for your study. So we had that 10.417 over 13. I almost said degrees of freedom, didn't I? But I caught myself. All right, so then we're going to work through this as well. Okay, so then again, there was some rounding going on with the 3 digits, but I get this as my denominator. So then I am going to go ahead and use that in my T formula. My T formula, again, because it's kind of arbitrary, but I said no COVID minus COVID, I am actually going to get a negative T this time, and that is okay. Again, I understand the context of that. Okay, then I'm having negative 3 over 1.266. And I am going to get negative 2.37. I am going to compare that negative 2.37 to over here, and we are in that great region of reject the null. So then I'm going to do my step 4. 1, reject the null. All right, I was in that critical boundary, critical region. 2, when you reject the null, things are statistically significant. 3, what does that mean? Again, I can say students had greater stress. And I can say COVID students had greater stress, although you have that negative T, you know this is my COVID group. So they did have greater stress. All right, so step 5, again, is effect size. Very important. We always do effect size regardless of our decision in step 4. So then we're going to be working through those same 2 formulas. Our eta squared. So our T we got was 2.37. Our degrees of freedom is going to be your degrees of freedom total. 24, and that's step 2, or that 12 plus 12. All right, so you're going to do that. You are also going to do your Cohen's d. Again, if you get a negative Cohen's d, you go through and you ignore the sign. All right, so on here, we got pooled variance. Again, its mean differences over standard deviation. Right, so my square root of SB squared is going to be my square root of that 10.417. All right, so, and then this guy is the same as our top of our T, which we got a negative 3. All right, so take a moment to work through those, and then we're going to work through the interpretation. All right, so let's work through step 5. So plugging and chugging. Again, I'm going to ignore the sign. I got 3 on the top, and then the square root of my pooled variance was for standard deviation was 3.228. Taking those, I get that 0.929. That is greater than 0.8, so I have a large effect, which does match my rejecting the null. I don't have a type 1 error. Again, type 1 error goes with rejecting the null. Then I could also have done my R squared. So taking these, putting them together, working through these, I get a 0.19. That 0.19 is interpreted in the variance and stress that's attributed to COVID, because that's my IB, or attributed to the IB. A variance in your DV that's attributed to your IB. And we've got that.